Hello dear students, welcome back to my YouTube channel. So as you know that yesterday we had a discussion on the point potential method, right? So in which we discussed couple of numericals from that particular topic, and I guess I have given you 5 numericals for your homework. Hello dear students, welcome back to my YouTube channel. So you are, I guess, and I hope that you okay. Good evening. So homework answers. Mm-hmm. It is okay. So yeah. So what we can do now? I will just do those numericals and you just cross check your answers. Okay. Okay. I get the screen is visible to you. I get the screen is visible to you now. Okay. So this is my first numerical. So how we can do it? Look, we need to find the resistance between A and B. So look, if the potential of this place is E, so look, no potential drop. So this one would be A, right? In a wire, no potential drop. So this point is also A. Done. This one is B, so this one would be B here. Let us suppose this point is C. So no potential drop, so this is C. This one is C, so you can go now in a wire with no potential drop. So the potential here will be C, no potential drop, here is C. Same case, no potential drop, this would be C, no potential drop, look, C, right? Here would be also C. So you will go here, potential is C. So how many points we have? Sir, we have 3 points, A, B, C. So I will make A point here, B point here, C point here. This one is between B and C. So this one is between B and C. So I will write between B and C with resistance R. This one is between C and C. So no use. This one is between C and C. No use. Okay. So we have this one between A and C. This one is between A and C. So I will make it between A and C. This one is between A and C. No? A and C. Okay. So these two are in parallel. So their R equivalent will be equals to R by 2. Okay. And now I can make it like this, R by 2 plus R. This one is R by 2. This one is R. I will add both things. It will become 3 by 2R. Answer is 3 by 2R. Right? Correct? You can see now. I will take my head now. You will see. Very easy. If you are doing the numerical couple of times now, so within no time you can do the numerical with 0% error. Okay. Okay. Now second homework numerical. Look now. Potential of this one would be C. This one is B. Now. Okay. Now look here. Let's suppose the potential of here is C. This one is C. This one is C. This one could be C, right? No potential drop. Here is also C, right? This one is C. This one is C. This one is C, and this one is C. Correct? Done. Look here now. If let's suppose look, this 4141 both are in series, so I will write 8 ohm. Na? So I can do one thing now. Look, I can do one thing. I will write 8 ohm here, right? 1 second. Instead of this one, I will write 8 ohm. Na? It will look like this now. Look, it will look like this now. 1, 2, 3, one more, like this, and here how much? This one is 4 ohm, right? 4 ohm, so this is 2 ohm. This one is 2, 2, 6, 3. Potential A, potential B, here potential C. The potential is C, right? Here is C. So here potential is C. You can see here potential is C, potential C, potential C, potential C. Done. Potential C. So I will write here potential D. So it will become D, D, D. How many points we have? A, B, C, D. Then no. CC, no potential drop, no current flow. CC, no potential drop, no current flow. So how many resistors we have? Sir, 1, 2, 3, 4. So we have one student with Sangarit Kaur. And Sangarit Kaur is celebrating birthday, right? So happy birthday, beta. And it is your dedication, no? It is your dedication that you are having your birthday today and still you're studying something, right? Great. Look, the only thing now for the success is consistency. If you are managing your all these things now, it shows that you are giving priority to your study, and it is very great thing, right? And happy birthday, beta. Happy birthday. So we are having one resistor. So I will write here A point. Then we have B point. Then D point. This one is between A and D. So A and D, it is 3 ohm now. This one is between B and C. It is B and no B and C. We have C here also here C. It is B and C. B and C is 6 ohm. This two is between B. Look, this is D and C. D and C. This one too. This one is D and C. So D and C is like this. Look, this two, both are in parallel, so their equivalent will be 1. Equivalent of these to be 1 ohm. So we have like this now. Look, 1, 2, 3. 6 ohm, 1 ohm, 3. I guess my answer came out to be 10 now. So my equivalent will be 10 ohm. Check your answer. Check your answer. Is it 10 ohm? You need to check your answer. Look, I am not now. Now look, in previous classes, I was doing step by step, right? But now, don't expect from me now that I am going to do the step by step now. I will be doing like this now. Okay. So every time now, you need to just put your hard work. Okay. That gives you some result. If I am doing some sort of no spoon feeding, nothing will happen with that thing, no. Look, if I am doing some shortcuts, no, so you need to think how sir manipulate this point, how sir got this point. So you need to learn this point from the previous classes. That's why I'm doing this calculation, no? And in the examination also you need to do calculation like this. Look, within 20 seconds I got my answer. And if you want to be the doctor, no, within fractions of seconds you need to get your answer. You need to say, you have to save your patients. You won't get a much time that you want to save the patient, no? You will get a critical patient. So you need to be very quick. That's why. Question number 3. Same potential method. If potential here is A, look, potential here will be A. Same wire, same potential. So potential of there will be A only, right? Here is potential B. Potential B, same potential will from this particular wire is B. So I will make 2 points, A, B. This one is between A and B. So I will write between A and B. R. This one is between A and B. One more between A and B. This one between A and B. One more between A and B. R, R, R. I guess my R equivalent came out to be R by 3. You can count the seconds also, right? Easy? Easy or super easy? R by 3, yes. And these are some very easy numericals, right? If you have any doubt now, you can just ask me here, right? Now question number 4. Question number 4 is resistance of n resistors. You can see here resistance of n resistors each having R ohm. When connected in parallel gives an equivalent resistance of R ohm. Question number 4. It simply indicates that, sir, we are having n resistors. One resistor, second resistor, third, up to n resistor. Each is having value R, 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 R if we are joining them in a parallel way. If we are joining them in a parallel, right? So what is the answer? Sir, we got to know that their R equivalent will be R by N. And this R equivalent is given to us. Sir, it is R. So I will write R equals to R by N, equation number first. Equation number first. The second condition, if these resistors were connected in series. Now we are connected the resistors series, right? Up to N. R, 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 R. I guess their resistance will be R equivalent will be equals to N times R. But what is R equivalent? So it is N times R, right? Okay, so I will write N. So here from this equation, I will write small r equals to R times N. So I will write it N times R. My answer is N square into R. This one is my answer. Next answer is R N square. Perfect. Good vibe is doing the homework, no? Homework simply indicates that you are coming in my class not for time pass. You actually want something, right? You actually want something. It is not the time pass thing. So if you want to do some time pass, you can watch multiple movies, right? But if you are coming for something, no, and if you are watching the lecture, by watching only the lecture, nothing will happen with it, no. You have to spend some time at your place. Great. एक तो सही मतलब बहुत कुछ हुआ. Out of 5 numericals, if you are getting a single numerical done, no, or if कोई भी numerical you are not getting very done, right? You are not getting correct answer. Getting answer right or wrong is something different, but you are trying the question, no? That is a big thing. You are trying the question. That is a big thing. You are spending your time. You may have your leisure time. No? You are spending your leisure time to get something done. No? It simply gives you the way of utilizing your time to get something great in your life. Okay, now question number 5. Question number 5. Okay, now we will do question number 5. And question number 5 is giving a statement. We have a wire of R resistance. That means wire with length L, resistance is R. We are cutting the into 5 equal parts. So 1 equal part, 2, 3, 4, and 5. So length will be R L by 5, na? L by 5, L by 5, L by 5, and L by 5. If the resistance is R, it will become R by 5, right? Why, sir? Because resistance is proportional to the length, na? R by 5, R by 5, and R by 5. If these parts are joined parallelly, so now I need to join all these parallelly, right? That means 1, 2, 3, 4, 5. With resistance R by 5, R by 5, R by 5, R by 5, R by 5. So how to get now R equivalent? It is simple, better now. What, sir? So we have, look how to get it now. So R equivalent will be R by N. What is R? R is R by 5 and N is 5. So I guess my answer is R by 25. Next answer is R by 25. Correct, beta. Good vibes, correct. Okay, this one is also correct, no? R by 25. Yeah, this one is correct. Congratulations. Now, in physics, if we want to calculate one single quantity, look now. So from previous two classes, we only calculate resistance, no? So if we have different numerical, we need to apply some different formula. But every time, now when I was in my classes, now when I was studying, now I was also very weak. But after spending my time, okay, honestly, dedicatedly, so after spending so much time, I when solving hundreds of numericals, so I got my way now. So now I need to get this thing done like that. Now I need to spend more and more time. So I have to give more time to my weaker portion. A time will eventually come now that I will be very good in solving the numericals. If I am doing now, why I am doing this numerical in a very quick way, just like a piece of cake? Because back in my days, and still I am doing the numericals. As a teacher, I am spending more than 3 hours, right? Daily solving DPP, solving modules of different institutions. Why? Okay. So as a teacher, if I am spending that much of time, no. So being a student, you want to something great, no? Mahadi, walaikum salam, beta. And there is no need to study me, no. I have everything in my mind. But still, I want to be a plus one teacher, no. Every time I want to just upgrade myself. That's why I'm spending. I'm taking this much time. Okay. Now one more. No. Firstly, we were having a resistance, na, the parallel and the series. Then second was the only seeing the diagram and getting it done. Third is point potential method. Now we are going to study now symmetrical method. Okay, one more technique to get my resistance, and this is also a very good one, an interesting one. It is symmetrical line technique. Symmetrical line technique. Symmetrical line technique. So how to apply it? We have two things. When we are applying this kind of technique now, we need to just take care of two things. Firstly, draw a perpendicular bisector about the points or plane of symmetry, or you can write mirror image, right? I guess from your organic chemistry, you may have the idea now what mirror image is all about, no? Chirality, okay? DNL, I guess, mirror image. Second one is we need to stretch then, okay? Stretch line. So now we know now the symmetrical line technique is comprises two steps. One is we need to draw a line, and the line should be perpendicular bisector to my potential points, right? And we need to draw the line so that it will cut my plane into two mirror images. Second part is we need to centralize the line. Okay, we know the basics of it. Now we will see how it works. Now we will see how it works. First one, look now. So look, if we are having a numerical like this one is the numerical. Point P and point Q. Each resistor is having resistance R. Okay. If I just ask you find the equivalent resistance, I guess you can do it very quickly. Now why? Because the upper two belongs to the series, lower two belongs to the series. It will become 2R, lower become 2R. Then 2R is parallel. You will get an answer of what? Huh? R only. Now suppose one more line. solve it. Still you can solve it now. Look, these two are in series, these two are in series, these two are in series. You can do it. Without applying this method, you can do it now. Now suppose we have a line like this. Suppose we have a line like this. Now solve it. Now we have a line like this. Now solve it. That's not how we can do it. You cannot say now which one is series and which one is parallel. You can see now. You cannot see and you cannot comment on it. But it is mixed now. So solving this kind of numerical, you need a different technique known as symmetrical line technique. Okay, what first step is all about? Look, draw a perpendicular bisector about the pointers. So we have 2 pointers. Look, Q point and P point. So we need to apply or draw a perpendicular. But still, look, we can draw a perpendicular here also. We can draw a perpendicular here also. We can draw perpendicular line here also or here also, right? There are numerous ways. But look, we need to draw it so that it can divide the plane into mirror images. It needed to into a mirror image, right? So how to just cut it into mirror image now? Look, I will show you now. I will show you. Look, if we will cut it from the middle, if we cut it from the middle, look, from this particular point, if we cut it from the middle, you can see now. Look, from this particular portion and the left one, if you are just commenting on this particular portion or this one, okay, so these becomes mirror image to one another. I guess you can see it very clearly now. Left side will become right side is mirror image. So yes, this is point number first. Second one is we need to stretch it. We need to stretch it. Whenever we are stretching the line now, it will get cut. It will get cut from this point, no? It will get cut. So I will make this diagram now like this. Look, I will make it like this. It will get cut now. R, 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 and R. P and Q, like. Look, no current will flow through this one. Why? Because it is open. No current will flow from this one because it is open now. Look, here from this particular one it is open. No current will flow from this one. Same, no current will flow from this one. If no current will flow from this one, so there is no fun of writing this one. No fun of writing this one. So now you can see this particular thing gets completely changed. Yes, it gets changed. So look now, these two are in series, these two series, these two series. I guess I need to write it like this now. 1, 2, 3. This is 2R, 2R, 2R. Point P and point Q. So what will be my R equivalent? Is it 2R by 3? Is it 2R by 3? Easy? Easy or very super easy? Huh? Easy or super easy? Super easy, no? Yes. So this is how we are dealing with these circuits. So look, you need to do couple of numericals so that you will have a very good understanding how to use this technique. Now one more numerical. I will show you 4 to 5 numericals so that you will get a very good understanding of these numericals. Okay. One more. It takes time. It takes time, no? PQ. Everyone is RR. This one is interesting. You will get something different here. Okay, this particular one. Look one. First point. So we need to draw perpendicular bisector, right? So that by crossing perpendicular bisector, that should divide the whole thing into two mirror images. So where from we need to cut it? Sir, from the middle one, no? Cut it. Second, stretch it. If you stretch it, no, so it will get cut from this end, no? These two ends, it will get cut from these two ends. Done. Now how to redraw the same thing, no? I know that it is some sort of boring now, but you need to just manage these things now. So look now, this one like this, get a cut. So like this. So they will get something like this, right? So everyone is RR. So you can see now there are difference between the previous one and this one. Look, you can see these two are in series. These two are in series. Series R plus R is 2R. RR is 2R. So just redraw the same thing now. R 2R. These two are in series. And answer is 2R. And same we have in downwards. 2R, R and R. And you can see this 2R and this R is parallel. This 2R and this R is parallel. So what is R equivalent? What is R equivalent of R and 2R? So if you want to get it now, look. So I will write 1 by R equivalent is 1 by R plus 1 by 2R. It will become 2 plus 1. It is how much? 3R divided by 2R square. R cancel out. It is, so my R equivalent came out to be 2 by 3 times R. Okay. So it is 2 by 3R. That means these two get 2 by 3R. These two get 2 by 3R. Okay. So what we can do now? Can just do one thing. One thing, better. 1 second. Okay. Done. Am I visible? Okay, now everything is good now. Okay, no issue, no. Look, so 2 by 3R, this one is 2 by 3R. So once again, we need to redraw the structure. This one is 2R. This one is R, no? R, R, 2 by 3R. Same, R, 2 by 3R, R. You can see 1, 2, 3. These three are in series. So I can write R plus 2 by 3R plus R. So you can write it how much? It is 2R plus 2 by 3 times R. So 3 to the 6, 7, 8. It is 8R by 3. Okay. The answer of these three is how much? 8R by 3, and these three is equals to 8R by 3. So once again, I need to draw the same structure now. So I will write it like this now. Look, 2R, this one is 8R by 3, 8R by 3. Now 8R by 3. So what is R equivalent now? R equivalent is 1 whole divided by 8R by 3 plus 1 divided by 8R by 3 plus 1 by 2R. I guess. Okay, now, so I need to write it like 3 by 8R multiplied by 2 times plus 1 by 2R. 2 on the 2, 2 fours are 8. It came out to be 3 by 2R plus 1 by 2R. It will be 4 by 2R. I think I am doing something wrong, no? Hmm? So, am I doing something wrong, no? Look now, look now, look now, look now. So I can just can do like this from, and it will become 1 by 8R. So it is 3 by 8R. 3 by 8R plus 1 by 2R. It will be 6 by 8R plus 1 by 2R. Same not. Okay. It is 3 by 4R plus 1 by 2R. Okay. So it will be 6. R is here. It will be 6. 6R plus 4R, 8R. So it is 10R. It is 10R is R square divided by 8R square. So my R equivalent came out to be 8R square by 10R. Cancel out, it will be 8R by 10. 2 4s are 8, 2 5s are 10. My answer is 4 by 5 times R. I guess this one is correct, no? This one is correct, no? Recheck this one. 4 by 5 times R. One second. One second, beta. So what is yours now? It is not coming 21 by, it is not coming 21 or 22. 5 by 4. 5 by 4. No. Look, basically, no. Look, it is 1 by R equivalent, no? So if we change it, R equivalent, so it gets reciprocal. It is 4. Okay. Then R. No, this answer is correct. It is 4 by 5 R. My answer is correct, no? It is correct. Okay, let's do a couple of numericals more now. Then we will shift to the next topic. Okay, next numerical. Same concept. Two resistors here like this, one like this. Point A, B. Resistance is only 1 ohm, 1 ohm, 1, 1, 1, 1, and 1. Done. Look, we will make it like this. It will get cut. This will get joined like this. So if I need to make a diagram of the same one now, the correct it now. Okay. I guess it will looks like this now. You can see the new one now. 1 ohm, 1, 1, 1, 1, 1, 1. Look, these two are in series, so their R equivalent will be how much? 2. 2 ohm, no? So I will just make one more. Now it is boring, no? Look, this one and this one is 2 also, so it is boring now making these diagrams. It is 2 ohm. Then 1 ohm, 1 ohm, 1 ohm, 2 ohm. Now this 1 ohm and 2 ohm is in what? It is in parallel, so I will write 2 multiplied by 1 divided by 2 plus 1. It is 2 by 3. So the R equivalent of these two came out to be 2 by 3. So one more time I need to make it. It is 2 ohm, 1, 2 by 3, 1. It is 1, 1, it is 2 by 3. Now look, these three, 1, 2, these three are in now series, right? It is 1 plus 1 plus 2 by 3. It came out to be 2 plus 2 by 3. It is 6 plus 2 by 3. It will be 8 by 3. It will be 8 by 3. It takes time. No, it takes time. 8 by 3. So I will make it like here, no? Here. So it would be like 2 ohm, and this much is how much? 8 by 3. So 1 by R equivalent came out to be 3 by 8 plus 1 by 2. It was 6 plus 8 divided by 16. So R equivalent came out to be 16 by 14. Done? So 2 at the 16 to the 14. Is 8 by 7? My answer is 8 by 7. Not 7 by 8, no, 8 by 7. Okay, one more, okay? One more. One more question. A couple of students are watching my lecture now, but only one student is taking benefits of my class, right? Okay, no issue. Each resistor is having value R, okay? Okay, So I think I need to cut it from this particular portion now. This one. I need to cut it from this particular portion. Okay. When you cut it, so this one get cut, this one get cut, this one get merged like this. It gets merged like this. R plus R 2R. 2R. R plus R 2R. 2R. R plus R is 2R. R plus R 2R. This one no flow, no flow. 1, 2, 3, 4. We have 4 resistors parallelly, right? So what will be R equivalent now? 2R by 4. R by 2 is my answer. Again, it takes now if we are doing it in a very shortcut way, it takes I guess 15 seconds or 20 seconds to get the answer. But basically, if we are doing it in 15-20 seconds, now we need to be very good confident on it. No? Okay. So in the first go, you won't be able to get it done. No? You will get confused. Okay. Definitely you will get confused. But you need to manage your these things, right? You need to get your these things done. Okay. If you have any confusion, you can ask me. No issue. Now today we will complete many topics. Then KVL, KCL. I guess we will try to complete next class. Okay. We are having 45 minutes left in our class. Look now. One of the most confusing one is ladder problem. We are having infinite ladder problem. Infinite ladder problem. How to deal with infinite ladder problems. Okay. So first of all, we need to make how the ladder looks like. Look. I will show you the way to do it, then a shortcut way also, okay? Because in our examination now, we may not have that much of time so that we can do it in a very step by step, okay? So there we need to apply shortcut. This one is 2 ohm, this one is 1 ohm. 2 ohm, 2 ohm, 1 ohm, and 1 ohm. Point A, point B. Point A and point B. We need to find it is equivalent resistance. So how to deal with it? Now, first point, what you need to do? So we have, look, this is 1 ohm, 2 ohm. Now the same thing repeats. Look here, sir, 1 ohm repeats, 2 ohm repeats. Now in a same symmetrical way, 1 ohm, 2 ohm, 1 ohm, 2 ohm, 1, 2, 1, 2, 1, 2, up to the infinite thing. What we can do now? Let us suppose if we are taking these things now. Suppose this infinite. Suppose R equivalent is equals to R. Suppose R equivalent is equals to R. So now redraw the same thing now. So can I make it like this now? Look. Look here. This one is R, 2 ohm, 1 ohm, point A and point B. Now see now. This R and this 2 both are in what? Parallel. So I guess what is R equivalent of these two? So it is R into 2 divided by 2 plus R. Redraw the same thing now. It will look like this now. Look. This one is 2R divided by 2 plus R. And this one is how much? 1 ohm. point A, point B. These two are in series. What is R equivalent now? Sir, R equivalent is 1 plus 2R whole divided by 2 plus R. If the resistance of whole thing is R, if let us suppose the resistance of 1 lakh terms, if the 1 lakh, we have 1 lakh term, no? If the resistance of 1 lakh term is R and we are adding one term more, I guess 1 lakh plus 1 is approximately 1 lakh only. There will be a minute effect in a look. If 1 lakh resistance is R, so what will be the resistance of 1 lakh plus 1? Sir, same, it will be R, approximately R. There is no issue. Clear, no? Short trick. So what I can do here, sir, this R will be also R. So I will do cross multiplication now. Look, it will be 2 plus R plus 2R whole divided by 2 plus R. Now I can write R into 2 plus R, then it is how much? 2 plus 3R. It will become 2R plus R square minus 2 minus 3R equals to 0. So I can write R square minus R minus 2 equals to 0. This one become my quadratic equation. This one become my quadratic equation. So this is my quadratic equation. Now, what, sir? R square minus R minus 2. So if I need to simplify the quadratic equation, we have multiple ways. One is the middle term split, na? Then quadratic formula minus b plus minus root of b square minus 4ac divided by 2a. There are a couple of things, right? So I can use the middle term one. So I can write R square, then R, I can write R minus 2R plus R square. I can write like minus 2R plus R minus 2 equals to 0. Look, minus 2R plus R is minus R. Minus 2R into R is minus 2R square. Great. So I will take a common. It is R minus 2. R minus 2. It is plus 1. Therefore, R plus 1 either equals to 0 or R minus 2 is 0. So R came out to be minus 1 or R is plus 2. Done. So minus 1 is not possible. So R is 2. R is 2. So the equivalent resistance came out to be 2 here. The equivalent one came out to be 2 here. But look, every time it is not feasible, na? Every time it is not feasible to do these calculations. It is not feasible in the examinations. We can spend, let us suppose, 4 to 5 minutes to get one numerical done. So for that thing, we have a shortcut trick. But we have a shortcut trick. What a shortcut trick? First thing, what we need to do? Do a short circuit. Short circuit. What does this mean? Look, we know that this is R. This is 1 ohm. This one is 2 ohm. And here 2 ohm, right? Here we have then infinite number terms. We can just join it. Just join it without any resistance. This simply indicates short circuit. This means short circuit. Short circuit means, look, what will happen now? If you want to find R equivalent now, look, here is point A, point B. Potential is A. Look, potential of this wire will be B. So this is B also, right? Potential, same wire is B, same wire is B, same wire is B. Now, potential here is B, also here is B. So look, we have 2 points A and B. How many resistors between? Sir, 1 ohm. This one and this is B. No current will flow through this. So what is R equivalent? Sir, R equivalent is 1 ohm. Second point, open it. Open means 1, 2. This is 1 ohm, 2 ohm. Now this wire, make it open. Make it open. So now, if this is point A, point B, so resistance of here will be how much? B. Or we can do one thing now. There is no issue of writing this thing now. Look, what we can do here? current will flow only through this particular one. Okay, both 1 ohm and 2 ohm, these are in series. What is R equivalent? 3 ohm. So if we are doing open circuit, my answer is 3 ohm. If we are doing short circuit, my R is 1 ohm. So the original R will be less than 3 ohm but more than 1 ohm. So I guess only one number lies between 3 and 1, it is 2 ohm. So in the shortcut way, we got R ohm. By doing this much of calculation, still I got 2 ohm, right? It is a shortcut way. This one is a shortcut way. What is the convention for short circuit? Nothing, no. If you are doing short circuit, no, just connect these two lines without any resistance. If you want to do short circuit between any two pointers, what you need to do? Just join two pointers without any resistance. You need to join two pointers without any resistance, so you will get it short circuit. Done. One more numerical. If we are having something like this, now look. If we have something like this, up to infinite. So I don't need to place my old method now. Use shortcut trick now. First one. So I guess it is getting repeated from this one, no? So cut the whole one. So I need to write it like this. Look now. First point, make a short circuit. Second one, make a open circuit. Open. R, 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 R. So the R equivalent of this one would be R plus R is 2R. R equivalent of this one would be 3R. Done? So what will be my R equivalent? Less than 3R, more than 2R. This is my answer. So in your options, you will be having 4 options. So one will be the correct one. Done? Any confusion? No confusion now? Huh? One more homework. I will give a homework question, okay? A homework question. Okay? Done? So this one is your homework. In next class, we will be studying uh, switch problem. Okay? Switch on and off. This problem. Then KVL and KCL. In next class, KVL and KCL. Then we will be having switch on off. This one, and if time permits, so then we are having weights to tone bridge. Two conditions: balanced and unbalanced. Balanced and unbalanced. And then I will show you the short tricks also now how to get it done, right? In next class. So in lecture number, I guess today is 6, no? So this we will discuss in lecture number 7. Then in lecture number 8, we will discuss about cell, EMF, okay? Then TPV, combinations of cells. This thing we will discuss in the lecture number 8. I guess this whole chapter will take, I guess, 10 to 12 lectures. That means in this week, I guess in this week only, we will complete this one. In next week, we will take capacitor. That will take also 1 week. Then magnetic effect also 1 week, no? So my plan is to cover the whole syllabus before September. So yeah, definitely we will complete the whole thing, right? Thank you, Beta. Thank you. Yeah, if you have any doubts or anything like that, you can ask me, okay? If not, then I will need to just. If you have any sort of no feedback or anything like that, you can just ask me here, no? You can do one thing. You can just comment here of the your suggestions or your anything like that, okay? Or if you want something different from my classes, you can do one thing. You can just message me, or you can just comment, no? You want worksheet? Okay. I guess you are in my Telegram also, no? Yeah, we can do. Yeah, we can work on it. Because as you know, I have multiple classes in a day, no? Multiple classes. Okay, only after 10 o'clock I'm getting free, so I'm taking your classes. So yeah, if I will get some sort of time, no, I will work on it. Definitely, and I am just giving you, no, I am giving you the sheets also, no, in the Telegram group, the cheat sheets also. You will get a whole chapter in one page. I have provided you those things also, and after completion of lecture, I am going to provide the notes also. Yes, I will do one thing. I will be providing the DPPs also. Okay, and for the DPPs, I will be taking a one lecture in Sundays. That's about I will give you a 50 or 100 top numericals. I am working on it. What I can do, I will take 100 numericals or 200 numericals from electrostatics, and I will be giving you the 100 or 200 numericals in my Telegram group. Okay, and I will be providing you the 1 week time. That means, let us suppose from 1 to 6, you need to complete your whole 100 or 200 top numericals from the particular chapter. Then on Sunday, I will be scheduling a meeting or a class where I will be discussing each one numerical, 100, 200, top 200 or 100 numericals. I am working on it, right? And then nothing, yeah, it will take 2 hours, right? So if you're taking a weekend Gaya, but when you will get a very good result, right? So it is not like this thing now that you will just mug up all these things. You need to get something in your mind also. Okay, be a good student. You need to spend at least couple of hours for a single subject. It is not like you will watch a lecture just like a movie and you will get your examinations done, right? It is not like that. You can see the competition level now, and you can see the NTA mood also. So let us hope for the best. And I guess tomorrow we won't have any class. I need to reschedule tomorrow's class because of my some work. So I will just update you in the Telegram group, right? So for now, bye. Take care, beta. Bye.